Hi everyone, good to see so many of you here. I'm Christoff Lutteroth from the University of Bath. I'm a senior lecturer in computer science. My specialty is human-computer interaction, and I'm particularly excited about applications of VR. So how can we use VR to make people healthier, to make them fitter, to rehabilitate them, or to help them learn interesting things? So today I'm speaking about virtual reality exergaming. And let me first introduce certain centers that I'm affiliated with. So you probably know the University of Bath. And there is a center you might have heard about, which is called Camera. Camera looks into motion tracking mostly. So it's the Center for the Analysis of Motion, Entertainment, and Applications. And they develop exciting technology that allows you to track people in motion, for example, for athletics, for sprinting, helping people to optimize their performance, but also for other applications in the entertainment industry. So we've got strong links there. And there's also a newer center that I'm affiliated with, which has the nice name MAVE, the Mixed and Augmented Reality and Virtual Environments Labs, which is basically all the people which are interested in VR and AR at the University of Bath put together. And you'd be surprised how many of them there are. So what's the problem I'd like to talk about today? Well, the big problem that you probably all know is physical inactivity. It's a leading cause of death and disease. And so what do we do about it? So we've got these massive problems on our hands. And when you look at it a bit more closely and you ask yourself, why are people physically inactive? Then there are two main hurdles for them to exercise. So one is usually time, not enough time. And the other one is lack of motivation. And as you may know, there are different types of motivation. And the most important motivation for exercise is what we call intrinsic motivation. So intrinsic motivation basically means doing something for its own sake, because you enjoy it. In contrast to extrinsic motivation, which is basically everything else, usually external rewards, that kind of thing, or self-image as perceived by others. And well, how can we make exercise more enjoyable, more intrinsically motivating? Well, we can add games. So not only physical inactivity is more enjoyable with games, but also physical activity. And that's exactly what we're looking at. Let's have a look at a little video. So this is me in our lab. I'm sitting on a cycle ergometer, and this is our exergame. So this is what I see through the HTC Vive here that I'm wearing. And so this is a simple racing game that we've recently evaluated. What we basically do with we implement these games, and then we run studies. So it's not enough for us to just know that these games look nice, that they somehow are enjoyable, but we are actually measuring lots of different things, from power output during exercise to intrinsic motivation and flow and immersion using validated questionnaires. And based on that, we try to draw conclusions that other people, like you for example, can apply in their own exergames. So this is the really hard part here, so I'm really struggling here. So let's have a look what it actually entails to design such an exergame. And I'd like to start off with another game, and you're the players, which is called Spot the Hazard. So this is a typical exergaming setup as we are using it. And there are 5 hazards here, and I would like to challenge you to give me some hazards. So let's start from the top. Who can tell me one of those hazards? Just shout it in. What was that?
The cable.
Yeah, absolutely. Very good, cable. Anything else at the top? What could be a hazard here?
Human.
Absolutely, human. Always a hazard, big hazard. Anything else? Okay, let's start with my list. So collision. You'd be surprised how easy it is for Lindsay to hit the furniture or even hit the bike while exercising, while wearing this headset, because he's essentially blind to his environment, right? So just to give you an example, we had one exergame where you had to duck under a bridge while you were cycling. And you'd be surprised how many people almost knocked their head on the handlebar of the bike because they simply didn't see it. So collision is definitely something we have to take care of. And when you think about this headset and you think about exercise, so what does usually happen when you exercise? Absolutely. So these headsets, the foam can get really, really sweaty. And if you don't clean it properly, that can get really, really yucky. Yes, and it fogs up your lenses. It's really unpleasant. Yes, so we actually have to design the EXA games that, they push people, but you don't want to push people so that they sweat all the time. And you also need to make sure that your headset can actually bear the sweat, that you protect it accordingly. So what else have we got? We already got the cables, so very easy to trip up or to even injure yourself if you're not careful. And what else is there? When you just think about Lindsay here sitting on this exercycle, what could happen? What do you think? Fall off, exactly. So falling is a problem. And when you're developing EXA games, you want people to move a lot. And if they don't see anything, there's always a danger that they trip over, that they fall off the equipment. And that's why it's really important that to give people a stable base. So people need to be sitting and holding on to the handlebars, and then we can mitigate those risks. And so we already had the human, yes? And so what do humans do when they play games? Well, sometimes they kind of get carried away with the games, and that can exactly happen with EXA games. And the problem is, even people who are not used to exercise can very much get carried away with the games. And that usually means that they overexert themselves, and that can be dangerous. So people can get, heart symptoms, and that's why it's important that the game actually controls that, especially when people are playing the game alone. So one way to control this is by monitoring the player's heart rate, and to make sure if that heart rate gets too high, then you better wind down the game and make sure that they don't overexert themselves. All right, so what else have we got? What other big challenges have we got with virtual reality, not just with games? So have a look at this video and tell me, how do you feel after looking at this? So this is somebody on a trike, yes, going left and right. Yes, you kind of have to get the momentum by doing this motion. And the person on the trike assured me that for him this was perfectly fine going on the trike. But looking at it, I get sick after a while when I look at that. Anyone feeling sick here looking at that video? Yes, you're not alone. There are actually quite a lot of people who get motion sick. And we've got something similar in VR, which is called VR sickness, which is slightly different than motion sickness, but very much related. So you see, depending on which statistics you look at, you've got a quarter or up to half people who get motion sick in some circumstance, and then you've got around 10%, sometimes more, sometimes less, depending on the VR technology you're using, that get VR sick. And so why do people get sick? Well, the main theory is that of sensory conflict. So we've got our vision system, we see movement in the game, but we also feel how our body moves. We've got the vestibular system in our ear, which is basically the accelerometer in our body. And if these two senses don't match up, that's one of the things that can make us sick really, really quickly. Yes. So we have to make sure that any motion that we perceive with our eyes in virtual reality is somehow matched up with an actual physical motion as much as possible. But the thing, of course, in VR, it's not always possible. We can't always make the body feel all those motions because usually we're just sitting there, right, on the spot. We don't really move much. So what can we do about it? Well, let's have a look at our game here. So probably the most important thing is to avoid certain types of motions. So any voluntary motion by the player is fine. So when I turn my head and I'm nicely tracked by the headset and the headset does the tracking well, then I won't get motion sick. That's fine because I induce the motion and I feel the motion that I do myself. But for example, in this game, I'm moving left and right along this road, and in reality, I'm not really doing that motion. I'm sitting stationary on the bike. So this can be a problem. And in particular, there are two types of motions which are really tricky, which is rotational movements, anything that creates a lot of optical flow, and also backwards movements in particular can be very problematic. And so a big thing is avoiding these types of movements or preparing the player when these types of movements happen. And how did we address this in our game? Well, basically, you can't rotate the bike. So usually when you're controlling a bike, you would rotate the handlebar and it would change the angle in which your bike goes, but we don't do that. In our case, the player moves left or right along this road just by tilting the head slightly left or right, and it's a complete lateral movement, like stepping to the side, so no rotation at all. That helps a lot in reducing VR sickness. Another thing that we do, whenever we want to, for example, put the player on par with our competitor here, then we don't move the player artificially. Yes? So movement is very much correlated with your exertion on the exercise. So when you pedal, then you move forward. That again mitigates motion sickness, VR sickness. And if we want to move the player more than that, we teleport the player nice and gently. That's another thing that helps. And the last thing is, it helps adding static frames of reference. So what kind of static frame of reference have we got here? We've got this handlebar, which is there where your real bike handlebar is, and that helps people keep their orientation and avoid VR sickness. Now, what is the magic sauce that we put into our EXA games, which worked for us? Well, one of the ingredients is high-intensity interval training, for short HIIT. So when designing an EXA game, it can be useful to look at some sports and exercise literature and see, what do these guys have found out about exercise? What are good ways to exercise that keep people motivated and also that can easily be translated into a game? And so you probably have heard about HIIT training. HIIT training basically means you've got bouts of really high, hard-intensity exercise interspersed by these relaxing, low-intensity intervals. And the nice thing about HIIT training is that you can essentially cut the time that you need to exercise to stay fit in half compared to this continuous exertion training. So, and another nice thing about it is, well, you can reduce the time that you have to wear the headset, etc. So you can reduce the discomfort, reduce the sweat, etc. And you can also gamify it. So games can actually help you to adhere to this protocol of these high-intensity spikes. So we did that by introducing different moods to the game, like a nighttime, high-octane race for the high-intensity phases and a nice, relaxing daytime scene for the rest. So what else is there? Well, the last thing I'd like to tell you about, which is more important than you might think, is about competition. So we add competition to the game. Competition is a nice incentive to get people exercising. And the thing about competition is there are different types. So here you see we've got this avatar, which basically looks like yourself. And this avatar could be somebody else. It could be a multiplayer game. It could be a virtual avatar. But what we in particular look at is to make this avatar a representation of your own previous performance. So basically a ghost, as it's commonly called. And this is really, really interesting because, well, what do you think if you were racing against your own ghost or racing against somebody else? Which one would you find more motivating? Who would find it more motivating to race against somebody else? Okay, who would find it more motivating against yourself? Okay, so you're not alone. So what we do is we show people at the beginning of the competitive race, we show them the avatar and we tell them this is you. So we make sure they understand that this is actually your previous performance. Yes, this is just a recording of your previous gameplay. Now you can do it again. Let's see if you can do it better. And we found that it makes a huge difference, not only for motivation, but also for how hard they exercise. So let's have a look at some graphs. So this is the sciencey part here. So this is delta power. This is basically compared to just cycling alone, how much more power do they put into their exercise? And we've got two conditions here. We've got a condition called E, which is the easy condition, where the ghost is just as good, but no better than your own previous performance. And then we've got an H condition, the hard condition, where the ghost is actually a bit better, where we are making it a bit harder for the player to overtake the ghost. And as you can see, so in the easy mode, the bottom line is non-self competition, so that's against somebody else, and the top line is self-competition, that's competing against yourself. And in this case, the way we compared these two is in both cases, people were actually competing against their own ghost. Only for the SC, we actually told them, this is your own ghost. And for the NSC condition, it was exactly the same, but we told them, this is just a virtual avatar. This is some virtual competitor. So they didn't know that it was themselves, but it actually was. And as you can see, as we make the ghost a little bit faster or make it a bit harder for the player to compete, the performance goes way up for the self-competition, but it doesn't significantly increase for the non-self competition. So people feel much more motivated competing against themselves. And when we look at intrinsic motivation, so intrinsic motivation can be measured with validated questionnaires, and this is also quite an interesting pattern. So the baseline here, the B condition, is basically just racing without any competitor. And you see here, it doesn't really make a difference. There's no significant difference. People already know they will race against somebody else, either themselves or somebody else, but the differences are not significant. And as they compete against their own performance on the same level of performance, you can already see that for the self-competition, the intrinsic motivation actually goes up a little bit. So people feel excited competing against themselves. They don't feel more excited competing against somebody else. And when we make it a bit harder, so when we make the competitor a bit harder to beat, then you see it actually really drops off here, the motivation, when people think they're competing against somebody else. Whereas if they're competing against themselves, it actually stays on the same level, no significant differences. So if you would like to hear more about this, there's a YouTube video about a recent paper that we published, and also please do email me. So I'm really keen to get in touch with anyone who would like to know more about this. Thank you very much.